Okay, hi everyone. Today we're going to go into factoring once again. This is a review. This is the last day, pretty much we're doing a review. This is our Smart Start. And we're going to go ahead and continue our trek into Algebra 2. So we're going to work on factoring again. And we're going to work on specifically factoring quadratics. So let's do something easy. Let's do x squared plus 6x plus 8. And when we factor, we're undoing the multiplication. And the way we get these trinomials, this is what we call trinomial. Or we also call these quadratics. We call these quadratics because of the x squared. Is that we multiply two binomials. X and x multiply to become x squared. And the trick was, since this is what I called a level 1 problem, you only have to look at the last term because there's an invisible 1 in the front. So what numbers multiply to become 8? We have 1 and 8 and 2 and 4. And the hint was this: if it's a plus sign, which of these add up to become the middle number 6? Which of these add up to become the middle number 6? 1 plus 8 is 9. Doesn't work. 2 plus 4 is 6. Hey, we found the pair that works. So we know it's going to be 2 and 4. Again, 2 times 4 is 8, and x times x is x squared. Now the things we have to include the sign, and we want to make sure you get the sign correct. Now if it's a plus plus, we know for sure that's a plus plus, easy peasy. Okay, plus 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 plus, because 2x, oops, that's an x, plus 4x is our 6x that we needed, right? That's our middle term. I'm going to change this a little bit up. X squared minus 6x plus 8. We still have the same idea here, except I changed the middle term here, just so you guys can see that. So again, level 1 problem because the front coefficient is an invisible 1, so that's easy peasy. 1, 8, and 2 and 4. 1, 8, 2, and 4. Which of these add up to become 6 in the middle? Now, why is it that a plus means add and a subtraction means subtract? Well, the reason why is when I multiply two numbers, either these numbers, let me write this a little bigger. To get a positive, either these numbers have to be positive, positive, or negative, negative. These are my only choices. It cannot be plus 1 and minus 8. Because a positive 1 times negative 8 would give me a negative third term. So if it's a plus, we know it's either going to be plus, plus, or minus, minus. So either if it's plus, plus, or minus, minus, we're going to be adding these terms. If it was a plus, minus, we would be subtracting the terms. So again, the hint is if it's a plus, plus, we know it's either going to be, if we know it's a positive at the end, it's either going to be plus, plus, or minus, minus. So in this case, I need to get negative 6. So which of these options give me negative 6? Would they both be positive or both be negative? They're going to be both be negative. So x and x, 2 and 4. I always write the numbers first. Those are the hardest. And now the sign, to become a negative 6, I need a negative 2 and a negative 4. Okay, let's kick this up a notch. Let's throw a number. Here we go. Let's give this 2x squared plus 11x plus 12. Okay, here's the next problem. Now, this is what I call a level 2 problem, because now there's a number in the front. And now, when there's numbers in the front, we have to be careful, because now we have more possibilities. Because in this case, it's going to be a 2x and an x. Would you agree 2x times x is 2x squared in the front? Now, the way I do this is because we're multiplying 2 times everybody, we actually have to short our combinations out. So the way we get 2 is 2 times 1. And the way we get 12 is 1 times 12, and 2 times 6, and 3 times 4. I'm writing out all the possibilities so I can see all the possible combinations. It's like going to a buffet. You want to see the buffet before you pick up anything. Now we're going to find a combination that adds up to 11. Now we're going to multiply a number in front and a number in back. And I called this before speed dating. We're going to speed date as fast as possible. 2 times 1 is 2. 1 times 12 is 12. 12 plus 2 is 14. That's not 11. Switch. 2 times 12 is 24. That's way too big. Okay, I'm done with this. 1 and 12 doesn't work. 2 times 2 is 4. 1 times 6 is 6. 4 plus 6 is 10. That doesn't work. 2 times 12 is, no, 2 times 6 is 12. 1 times 2 is 2. 12 plus 2 is 14. That doesn't work. And then 2 times 3 is 6. 1 times 4 is 4. 6 plus 4 is 10. That doesn't work. 2 times 4 is 8. And 1 times 3 is 3. 8 plus 3 is the 11 that we needed. Okay, so we multiplied 2 times 4 and 1 times 3. And that's the combination you want to make sure you hit. Now, the way I try to make this a little easier for you guys is that I had you guys draw a little frog face. We said, hey, we multiply, in order to get these terms right, the right order, I drew this little frog face here, a little dead frog. And we said 2 times 3 or 2 times 4. 2 times 4, so this has to be 3. And in this case, it's going to be a 3x and an 8x, right? 3x and 8x, I want them both to be positive, plus plus, to end up with positive 11. Okay. Now, let's try another one. Okay, let me give you another problem. Let's do, so I want you guys to try this real quick. Let's do 3x squared. I'll do plus 8. And then I'm going to say it's going to be minus 16x. Wait, nope, sorry. Wrong number. 14x. Okay, I want you guys to go ahead and factor this. I'm going to help you out by writing out the numbers and see if you can see the combination quickly. Do any of these combinations, when you multiply them out, give you that 14 that you need? We know that we have to choose 3 and 1, but would you use 1 and 8 or 2 and 4 to finish your combination to get 14? So you can speed date. 3 times 1, 1 times 8, that would give you 11. That's not the number I want. 3 times 8 would be 24. That's already too large. Let's try the next date. 3 times 2 is 6. 1 times 4 is 4. 6 plus 4 is 10. Nope, doesn't work. But hey, 3 times 4 is 12. 1 times 2 is 2. That does give us the combination we wanted. 12 plus 2 is 14. So we for sure are going to use 3x and x. Who'd you multiply the 3 by? I multiplied it by the 4. And then we're going to write the 2 on the other one. And since this is minus 14, they both have to be negative, because negative 2 and negative 12 gives us that negative 14. If you do need help with this, you can stay after class. I can help you guys some more factoring this. Okay, so let's get into level 3 factoring problems. Again, this is just a review. This is stuff that we covered before, but I'll make sure we spend some time with it. Here we go. Here's another problem. 12x squared minus 12x minus 9. Now, here is a trick about factoring. Do you see any common factors or common terms I can factor out in 12, 12, and 9? 12, 12, and 9. Are there any factors I can factor out? And I'm thinking I can see a common 3 involved. So you might want to factor out a common factor first. And this actually makes your problem slightly easier. Now we're back stuck with what I still call a level 2 in this case, because there's more than one option here. The possibilities to end up with 4 is 4 and 1 and 4 and 2 and 2. And 3 is 1 and 3. These are my only options. And we're going to speed date. And in this case, we're going to subtract out to become 4, right? We're going to subtract out to become 4. Let's see if you guys can quickly see the option. Which of these possibilities, when I multiply them out, would become a 4? 1, 1 is 1. 4, 3 is 12. 12 and 1 does not make 4. Flip. 4 times 1 is 4. 1 times 3 is 3. 4 minus 3 is 1. Nope, that's not an option. 2 times 1 is 2. 2 times 3 is 6. 6 minus 2 is 4. So here's my option. Hopefully you can see that quickly. And if you're not sure how I'm combining the numbers, please let me know. So we have a 2x for sure and 2x. That's what we said. The front has to be 2 and 2. The back, we said we multiply this by, it doesn't matter because they're the same number, but I'm going to say 2 times 3 and 1. Right? 1 times 3 is 3. Now, we need the negatives to win. So do you want 2 here to be bigger, or do you want 6 to be bigger? Well, 6 is bigger, sorry. I want 6 to be bigger and negative, because I need more negatives to win. And a positive times negative is a negative in the back, right? A positive times negative gives me that negative 3 in the back. Okay, that's factoring. Let's do one more. This one looks a little more difficult. 9t squared. I'm copying this one from IXL this time. Now these are huge numbers, okay? And if I want to write them all down, 9 would be 1, 9, 3, and 3, and 24 would be a lot more options. 1, 24, 2, and 12, 3, and 8, 4, and 6, right? That's a lot of options. But I could factor out one number to make this problem a little bit easier. I was asked in the chat, so what is the only thing that makes it a level 3 problem? Was a bigger number? It wasn't just a bigger number, it was more options. In my level 2 problem, the front value is only one option. It was only one option. But when I consider a level 3 problem is when, hey, it's more than one possibility, right? And this problem could take a little bit more time. It's not as obvious as a level 2 problem where there's only one option to check. And in this here case, let's go ahead and factor out a common value. I hear 3. Great, thank you. I know a 3 goes into 42. 4 plus 2 is 6. We can divide 6 by 3. And it does go into 24. So let's go ahead and take that out. 3t squared plus 3 goes into 4 one time. 3 goes into 12 4 times. And then plus 8. All right. Now, I would consider this a level 2 problem and when it comes to factoring levels, because take a look, it's only 3 and 1. That's my only option. In the back, it's going to be 1 and 8 and 2 and 4. So there's really not many possibilities here. Now, can you guys quickly spot which possibility here would add up to 14? Okay, since I wrote it out, take a look. You guys can multiply quickly, and I'm pretty sure you guys are good at checking really quick. So which of these add up to 14, and have you found it already? And did you find it in less than 10 seconds? If I go through my numbers, speed dating, 3 times 1 is 3, 1 times 8 is 8, 3 plus 8 is 11. Nope, flip. 3 times 8 is 24, that's too big. 3 times 2 is 6, 1 times 4 is 4, 6 plus 4 is 10, nope. But some of you guys might have seen already that 3 times 4 is 12, 1 times 2 is 2, and that's the number we needed, 12 and 2, since we're adding. All right, let's go ahead and set it up our binomials. We have 3x and x for sure. How do I know this? Well, not x, I'm sorry. We should write this as t. 3t and t, and 3t times t, right? They multiply to become 3t squared. The back numbers is 2 and 4. Now, you can't just flippantly just write 2 and 4, or 4 and 2 and 4, whichever order. We want to make sure I draw the little frog face to make sure I know which value I'm multiplying in which position. That's going to be a 4 because we needed the 12. And then we're going to put the 2 in the front. And the plus plus is the nice plus plus case. Double check. 2 plus 12 gives me the 14 we wanted. This guy looks like a creepy face thing. All right. So if you can master factoring, you guys are in a great position. Okay. Super, super cool. Now, we have 2 more types of factors that we want to work with today. Okay. And here you go. Let me show you them real quick. It's the square of a binomial. If I say x plus 2 squared, it's going to be x squared plus 4x plus 4. Now I want you to notice about this special factor. It's that if I want to factor it, isn't x squared really just the same value squared? How about 4? Isn't 4 also the same value squared? Now, when it's squared and squared, squared in the front and squared in the back, squared in the front and squared in the back, this might be, again, one of these special cases where you might be able to notice. So 2 times 2 is 4, and 2 plus 2 is 4. If I give you another one, x plus 3 squared. This would be x squared in the front and 9 in the back, and 3 plus 3 is 6x in the middle. So in these level 1 type problems, you square in the back, but you add in the middle, or you can say you times 2. Right? You square in the back and you double in the middle. Let's see if this works for a larger one. Let's give you another one. X squared plus 20x plus 100. Okay. So would this fit our little pattern here of square in the front, square in the back? Okay, this is really a square of a binomial, a perfect square. Isn't 10 times 10 100? And isn't 10 plus 10 the 20? Automatically we can say this is 10 squared. Let's give you guys another one. X squared plus 16x plus 8. So not 8, I'm sorry. I was thinking the answer in my head. 64. We're square in the front, or square in the back. Is 8 plus 8 16? It is. So this works specifically when it's a perfect square in the front and the back. Now, let me go ahead and add a couple values here. 4x squared, and we'll add a plus 9, and we're going to say this is 24x. Would this be a perfect square value? I see 2 and 2, right? And 3 and 3. And 2 times 3 and 2 times 3. This is 6 and 6, right? So this is actually not going to work. But I'm going to change this a little bit. What if I wrote, since we have the numbers 2, 2, and 3, 3, that's 6 plus 6, right? 6 plus 6. So that should have been 12. If I wrote 4x squared plus 12x plus 9, this would have been 2x, 2x, 3, and 3. And that would be 6 and 6 makes the 12. Now, let me give you the pattern, just a generic pattern. You don't need to memorize this, but this is helpful for some to see. Ax squared plus, ax plus b squared is equal to a squared x squared plus 2abx plus b squared. So here's the pattern. If you see it's a perfect square on the both, it's just you take the a and the b value, whatever you were squaring, and you multiply by 2, and that should be your middle term. What happened to the 12? The 12 was created by 3 times 2 is 6x, and 2 times 3 is 6x. 6x plus 6x is 12. This first one was not factorable for us. Yeah, it was 24 before. And to see that it doesn't always work for any random numbers. They have to combine to become that middle term. And that's how we can double check to make sure it does work. It's not the same equation, I'm sorry. So I changed the 24 to a 12, and then it was factorable. Okay, so let me give you guys another one. This one's a little larger. 25x squared. So we know that's a perfect square in the front. I'm going to give you guys a 16 in the back. Okay. Now, what do you think this middle term would have to be if this was factorable? 5x plus 4 squared. What do you think that middle term would have to be? You could try that, but it depends on the situation, and generally we would just say it's not factorable. Depends on what the question is. Okay. All right, so I see 5x plus 4. Now, let me write this out for you guys so you can see it. We know 5x and 5x is 25, x squared. We know 4 times 4 is 16. What was that middle term? We would need exactly the same 20x and 20x. 20x plus 20x is 40x. So the rule is simply this. If I just take the number in the front and take a number in the back and double it, 5 times 4 is 20 and double it, we end up with our middle term. Okay. Now, is this always obvious? No. If I had written this as 50x squared plus 80x plus 32, you would not have noticed that this would have been a perfect square model. So we go back and we say, hey, is there anything I can factor out in common? Sorry, that's 80. Between 50, 80, and 32. Well, can I divide them all both by 2? Then we have 25x squared plus 40x plus 16. Now, when you see problems like this, they're teasing you to say, hey, look, it's a perfect square model. They're really teasing you when you see problems like they're teasing you. And say, hey, well, isn't 25 5 and 5? Isn't 16 4 and 4? 5 and 5 and 4 and 4? Now, if I multiply across, isn't that 20 and 20 gives me the 40 we wanted? Oh, this is a perfect square model. So it'd be 5x plus 4 squared. It's a super tease. Does this work for negative signs? Yes, it does. If I wrote instead, let's give you as an easy one. If I wrote 25, looks ugly. If I did 25 x squared minus 40x plus 16, would this still have worked? 5 times 5 in the back, in the front, 4 times 4 in the back, and they still add up to 20, but instead of using a plus sign, we would use a minus sign in between, because this would be negative 20, and negative 20 gives us the negative 40. Okay, let me just reiterate. Let me show write this out so you can see it. So 5 times 5 in the front is the 25 we wanted. Everyone cool with that? In the back, negative 4 and negative 4 is the positive 16 we wanted. How about the middle term? This would have been negative 20x, and negative 20x gives us the negative 40. So these are perfect squares. Okay, when you're factoring, these are special cases where they're perfect squares, exactly the same. Let's do another one. Let's give ourselves 9x squared minus, we'll pick a number in the back first to make our lives easier, plus 16. Did we do this one right? I feel like we did this. There's only a couple of them you can do. Oh, no, we didn't. Okay. And what do you think the middle term is going to be? Help me come up with the middle term. This is 3 and 3 and 4 and 4. What do you think that middle term is going to be? Something x, right? 3 times 4 and 3 times 4, that's 12 and 12. So our middle term is going to be 24. Thank you. Good job. 24x, perfect. Now, if we would go backwards, since this is a perfect square, we know 3x, oh, that looks ugly, 3x and 3x and 4 in the back, we know for sure that's going to work right now. And since it's a minus, they both have to be negative. Now, why couldn't they be positive? If I said plus and plus, this would have been plus 12 and plus 12, which would have given us positive 24. So they're not positive. What if one was positive and one was negative? Which it's going to lead us to our next rule right now. If they're plus and minus, this would have been 9x squared. In the back would be minus 16. Okay, that doesn't match already. But also, let's take a look at the middle term. It's going to be plus 12x minus 12x. Look at the middle term. they're going to cancel out. And this gives us a whole new rule here. And this is going to give us 9x squared minus 16. And that's going to be a difference of 2 squares. And that leads us to our next rule. Let me go ahead and finish up this one here. This was going to be, we said 3x minus 4, right? So just so you have it. And then this line here is going to be a new problem. So this difference of two squares, oh, that's a CE, whoops. Difference of two squares is a simple model. If I see x squared minus 4, this is no longer a trinomial here, not a trinomial. But if you see a squared and a squared and you're subtracting them, it's always going to be this simple model. Whoops, that's a 2. Plus and minus. Why is there no middle term here for this perfect square? This difference of two squares? Okay, the front, x and x, of course, is x squared. The back, 2 and 2, of course, is 4, but that's going to be a negative 4. Now, I want you guys to look at the middle term. It's going to be plus 2 and minus 2. Plus 2x, minus 2x, and they will always cancel out, leaving us a square in the front and a square in the back. Now I'm going to throw a bunch of these for you real quickly out. If I say x squared minus 16, what do you think the two terms are? Is this a difference of two squares? A square and a square? It is. So our model is x, 4 and 4. And to cancel out the midterms with a plus and minus. They are identical twins, but one's good and one's evil. Even a different model. 9x squared minus 25. Does this fit our model? 9 and 25. Are these both squares? They are. Squares of what? And plus and minus. Okay, let's do one more. Let's do 81x squared minus 100. Okay, are these both a difference of two squares? Okay, this is our model of difference of two squares. The last thing I want to cover here is what we've been covering before, except I'm going to kick it up a notch. And the example is, what if I wrote x to the 4th plus 6x squared plus 8? Does this change that much of what we've been doing before? Well, if I say x squared and x squared, isn't it x to the 4th? What numbers multiplied become 8? 1, 8, 2, and 4. Do any of these guys add up to become 6? Yeah, 2 and 4. And this is us factoring. Not with x squared now, but with x to the 4th. Let's double check it. X squared times x squared is x to the 4th. In the back, 2 times 4 is 8, plus 8. And 2x squared and 4x squared, that gives us our 6x squared we wanted. So all the rules that we've been working on right now work if the exponent changes, but it always still has to match up in the end. You can't just, if this was a 3, this would not have worked. Okay. That's still a difference of two squares one. If I say x, let's say 9x to the 6 minus 4. Okay. Can I factor this? Is this a perfect square? That's 3x3 times 3x3. And that's 2 and 2, right? So yes, this is 3x cubed. 3x cubed. That's 2 and 2 and plus minus. What if I wrote, I'm going to use the 6's because those are a little harder. Let's use 9x to the 6 plus, let's say plus, let's do it 4, and then plus 3, plus 12x cubed. Does this work for our model? This is 3x cubed, right? This is 2 squared. 3 times 2 is 6. 6 plus 6 is 12. So our model is 3x cubed plus 2 squared. Okay, so you have to play with this a little bit for you to get a little better grasp of it. But as long as you have these models work out for you, I think the IXL will be fairly easy, okay?